going to start talking about right triangle trigonometric functions now. And to do that, we're going to look at a right triangle. So a triangle with a 90-degree angle in it. And we'll concentrate on this angle, alpha here, we'll say. And based on where this angle is, alpha, we're going to define some names for sides here. First thing we're going to do actually, and this actually doesn't depend on alpha, but the longest side of the right triangle is always the side opposite this 90-degree angle. So this side, this is always going to be your longest side, and the longest side we have a name for, we call this the hypotenuse. So that's the hypotenuse of a right triangle. And then when we're looking at angles, sometimes we're interested in this angle, sometimes we're interested in this angle, but we'll define the angle that whenever we're interested in is alpha, and let's just say this one. Then the side that is opposite this angle, we just simply call the opposite side. And the side that lies as the initial side to this angle, we call the adjacent side. And this is a pretty common layout for a right triangle. Adjacent, opposite, and hypotenuse. So the reason we do this is because we're going to define a couple functions here. We're going to define a function we call the sine, and we're going to define a function we call the cosine to start with. So the sine is a function that uses this angle. So the sine of alpha equals, and the way this is defined is it's the opposite side, the length of the opposite side, over the adjacent side. Opposite over adjacent. That's a good idea to memorize, actually, if you want to memorize another topic in mathematics. And then the cosine, we usually abbreviate as COS, cos. Sine we abbreviate SIN. So cosine of alpha equals the adjacent over the hypotenuse. Okay, back again. So this is the cosine is the adjacent over the hypotenuse, and I see I misspoke about the sign up there. I'm going to correct that. The sine is not opposite over adjacent, that's actually the tangent. The sine is opposite over hypotenuse, length of the hypotenuse. Okay? For example, let's say that we have this triangle here with these dimensions. This one side is 10, this other side is 5. We know that this is the longest side because this is the 90-degree angle. We can just scope that out. So we can figure out what the cosine, or the sine of this angle is. So the sine of alpha equals, well, actually, I need to know what the hypotenuse is. Of course, I can calculate this with Pythagorean's theorem, where, say this is A, this is B, so this is the square root of A squared plus B squared equals the square root of 10 squared plus 5 squared. And this is then the length of this hypotenuse is 5 times the square root of 5, which is approximately 11.8. And I'm satisfied with that. It's longer than this side, longer than that side. So the sine of alpha equals opposite over hypotenuse, which is 5 over 5 square root of 5, which is 1 over square root of 5. Cosine of alpha then is adjacent over our hypotenuse, which is 10 over 5 square root of 5, which is 2 over square root of 5. We have one more common trig function called the tangent of alpha. The tangent of alpha equals sine of alpha over the cosine of alpha, which if we substitute in up above, we have the opposite over the hypotenuse divided by the adjacent over the hypotenuse. So 1 over hypotenuse, 1 over hypotenuse, these hypotenuse can cancel out. And this equals the opposite over the adjacent. Here, the tangent of alpha then is 5 over 10 equals 1/2. And let's see what would happen if we put in the sine over cosine. I'll put it up here actually, since we have space. Sine over cosine equals, so you look up here, and what did we get for the sine? We got 1 over square root of 5 divided by 2 over square root of 5. So just like we did over there, we can end up canceling out the square root of 5, and we have 1/2 in that way too. So there's two different ways to calculate the tangent. Now there's some less common trig functions. The something we call the secant. And the secant is 1 over the cosine. Here I stretched this out with the abbreviation. And we have the cosecant equals CSC of alpha. This is 1 over the sine of alpha. And then we have the cotangent. Equals cot of alpha, which is 1 over the tangent of alpha, which is, instead of sine over cosine, is cosine of alpha over sine of alpha. So this is the hypotenuse over adjacent, and this is the hypotenuse over the opposite side, and then this is then adjacent over opposite. And these, of course, are just the reciprocals of our three main trigonometric functions.